So Green Tweet's composite focus, again, I want to lay the groundwork a little bit for what we're doing with discontinuous long fiber, and then we'll start discussing some of the advancements, some of the automation, some of the hybrid capabilities that we're developing. So some of the fun stuff that really hasn't been made too publicly yet. So I'm excited to have the opportunity to discuss it. So again, we are a part manufacturer and designer. We've developed all of the complementary capabilities, such as predictive from all the way from a mold design level to a fiber alignment level to an FE level, mechanical failures where the damage is going to occur. So that is our expertise. We're typically procuring materials, unidirectional tape, fabrics pre-impregnated from a variety of material suppliers. And then we're really going to, our IP, our special sauce is in the prediction and the processing of these parts and the generation of, repeatable components. Again, as I mentioned, the matrices that we're dealing with are PEEK, PEI, nylon, and PEKK, and predominantly commercial aerospace. And then any sort of mobility platform, such as defense, UAVs, AAM, and robotics that values the weight reduction. Anything that's looking for the removal of metallics and the optimization from a weight perspective. That's really where our specialty lies. And then we have some external fiber placement and extrusion partners that we'll leverage as well. Design considerations for these parts. Weight, of course, as I mentioned, impact, erosion, fire, solvent resistance, and thermal requirements. These matrices are excellent in solvent resistance, so all of your standard hydraulic fluids, aerospace fluids. And then from a thermal perspective, say for PEEK, the TG is around 289 degrees F, but we have brackets that are flying well above that. They have the ability to be thermocyclically without any degradation to the matrix itself. Unlike a thermoset, if you succeed or if you surpass that TG, the material is no longer usable.